Hey guys, welcome back to AlgoYogi. We are doing tree series right now, and our next problem in the list is sum root to leaf numbers. Let's go to the problem on LeetCode. Problem description is quite straightforward. You are given the root of a binary tree containing digits from 0 to 9. Only each root to leaf path in the tree represents a number. Basically, in this tree over here, one of the path is from root to 2, so 1 2, so 1 2 is 12, 12 is a number. Sorry, 1 3 13, that's also a number, and we need to return 12 plus 13, that is 25 as our answer. So quite really simple. And the way we're going to do is we will basically traverse our tree, and let's say we have our tree 1 2 3 and 4, and let's say 5. So one of the paths would be basically 1 to 2 to 3, and that makes a number 1 2 3, so 123. Another path would be this, that is 1 2 4, and another path would be 1 5, and we can sum all these up, which is 4 3 7 5 12 1 2 2 4 5 6, and basically 2. So that is the answer we're going to return. So to solve this problem now, we can use any of the traversal method, which is pre-order, post-order, and in order. And once we reach basically any of the leaf node, we basically keep track of our current string. Basically we can maintain some variable called current value or current string, and that basically will store, let's say we start over here at 1, so current string would be, or current value would be 1. Then when we go to 2, we can append 2 to it, so it's just like in a string. And then when we go to 3, we append 3. But we will have a condition where we check if it is a leaf node, basically checking if it doesn't have any right child or left and right. So that's when we know the path has completed, and that's when we can append that to our main answer. So we'll maintain like something called main answer, and we can convert this value into integer and append it to my answer, and from here return back to 2. And when we are returning back, so it will return the control, and this 3 will be removed. All right, so this 3 will be removed, and we're not removing it ourselves because the control was sent from 2, and here the current value was being maintained was 1 2. So from here now it will call 4, and same way it will basically append that to answer, and in a similar manner it will come back, on our call stack, come back to 1, and that will make the call to 5, and it will add 15 as well to our answer. So this is a really simple problem. Use any of the traversal method. I don't even know why it's marked a medium level problem. They could call it easily, simply, easy. But anyway, okay, we don't have any control on that, but what we have control over is writing our answer, and that is quite simple. Let's have a rest variable, which is basically creating an array because it's easy to reference inside an inner function, so we don't want any complications. Okay, all right, so let's call it DFS, which basically combines all pre-order, in order, post order into just one. So we're going to have root here, and then as I said, we can have current value, and if root is none, I'm not returning anything, so I'll just simply say return. I'm basically will be adding my answer to result depending on when I find a leaf node. So if root dot left is none and root dot right is none or as well. I love Python, man. Writing code is just like writing plain English. So now we can just append it to our answer, and that would be simply by converting it into integer. And what we are converting into integer, current value plus my root, but let me convert my root value, that digit, into a string first, so that I can concatenate that to my current value. So root dot val, and after converting into integer I can append that. Simple, easy. Now what? Only one remaining thing. You can call left and right problems, you know, in any order you like. So I'll just call it on left first and then right. All right, call it on right. Sorry, not like that. Root dot left and root dot right. And one more thing, this cur value needs to be updated with the current root value, because if we are in the middle, we need to append it to the previous value so that it can call its children, which are non-empty since they're not root. So mid values can be appended, you know, they add on to current value. So we'll convert it into a string and root dot value. All right, and same thing will be done with our right side as well. And I think, oh yes, since it's a base case we are creating, we need to return our control from here as well. We don't want to keep going on to the none nodes. All right, we could go, honestly, doesn't really matter because they will call on none, but what will happen is it will call on none and it might try to access null values, which is not good. All right, let's call our DFS on what? On our root, and initially we are sending just empty string, and this will be the case if it's just one root. It will start, you know, appending the root when it will call on left and right. So root value will be appended over here. Okay, then our result will be updated and we can finally just return the result. Not just result, the first element of our result, only element of our result. Let me zoom out and try to submit our answer. Right, awesome. Runs on the examples. Let's submit it to LeetCode. LeetCode 5%. Let me try again. Too easy. Just let me submit it. Come on, man. LeetCode sometimes just forces you to buy their subscription, honestly, like crazy. But anyway, I think it's a group of few engineers, really good people. I don't know them personally, but I don't even know. I'm just saying because they're helping, you know, like the platform was like such an add-on to preparing for these interviews. All right, let's go to our, oh yeah, we gotta write our time complexity here. So time complexity for this problem is just like other problem, big O of n, worst case, and even any case, because we are visiting all the nodes. Space complexity will be big O of h, which could be in worst case big O of n. So I'll just write h could be equal to n. Let's go to our AlgoYogi, mark this problem solved. See you guys in next problem. Until then, ta-ra, bye bye.